Hi guys, it's Ed. Recently I found this interesting tool here. It's called Infranodus. There are some YouTube videos. I can put the link in the description. This is basically a co-occurrence network, meaning that the nodes of this network here are words, and the links between the nodes are co-occurrences of these words in a sentence, for example, in a chunk of text. Now, you can think of it as a social network of words, and you have these words here that are basically more connected, more important. They have a lot of friends, other friend words, and then you can have also peripheral words that are, for example, connecting. Those are the friends connecting big important people, or they are in contact with big important persons that they have a lot of other friends, right? So the analogy here of a social network of words is very powerful, and that led me think about what if we create a social network of ideas. Well, that way we could have our own little graph with the ideas on the graph, and then we could perform some very cool analysis or apply graph algorithms, for example, to find clusters of ideas. Now, that is all fancy. The point is then, how do we represent an idea into a graph, into a network, in order to create this co-occurrence network of ideas or social network of ideas? And it turns out that, cognitive science did a lot of work, and it turns out that there are some theories in cognitive science that, especially, that can help us with this endeavor here. And one in particular is called the representational theory of mind. You're gonna put the links in the description for these documents here, for these pages. And that is a very interesting concept here. What the RTM says is that our thinking processes basically are based on mental states. So you start formulating some ideas in your brain that are basically mental states. You have a state in your mind that represents an entity or an object or a belief that you have about the world. For example, you see that here it says that the starting point is mental state. Okay, and these are, for example, thoughts, beliefs, desires, and so on. The RTM understands mental processes such like thinking, which is something that we are interested in because we want to kind of simulate these thoughts, these ideas, these thinking processes, put them into some sort of network as a sequence of intentional mental states. Okay, so we have that our thinking process, and we can go here and start writing some nice little information. We have that, put it Y, thinking process is equal to a sequence of mental state. So I can say mental state 1, then we have mental state 2, and so on. All right? Okay, so far so good. Now, the point is, all right, what is a mental state? Because if we can represent a mental state into a network, then we have our own thinking process into the network as a path. Now, turns out that a mental state is actually a mental representation. So let's go check it here. The mental states are related to mental representation and explains the intentionality of the former in terms of semantic properties of the latter. What are we saying here? We're saying that a mental state that has some intentionality, for example, believing something, is a mental representation with some semantics. So we can go ahead a step further and say that and then we're going to talk about mental representations as well. We're going to say that our sequence of mental states is actually a sequence of mental representation with their semantics, okay? Plus semantics, then mental representation is plus semantics, and so on, okay? So now we have this sequence of mental representations. Going back to our social network of ideas, a path is a sequence of mental representations with their semantics. So far, so good. Then we have to ask ourselves, okay, now how do we represent a mental representation with some semantic into the computer, into a program? Well, going a step further, we know that, according to this theory, mental representations are actually concepts. And here there is another little page that really explains well what the concepts are. And they say that the concepts are the building block of thoughts. Okay, so here now we're getting closer to our kind of goal to represent ideas into social network of ideas. So we have the concepts are building blocks of thought. And we go a little bit down. We have that actually concepts as mental representations. So we have the concepts are mental representations. Okay, let's see what it says. We are talking about the RTM as we were in this page here. So the RTM, according to RTM, thinking occurs in internal system of representations. That is what we were saying a second ago. And then we are saying that the mental representations, which is what we were looking at, involved in belief and other propositional attitudes, they have some internal structure. Okay, so we adopt the mental representation view of concepts. Concepts are identified with these more basic representations. That's great. So mental representation is made, they have the structure, it is composed of building blocks. These building blocks are concepts, and that is great. Early advocates of RTM and so on called these more basic representations ideas and often took them to be mental images. So now you see that we are kind of closing the loop here. So we are saying that a thinking process is a sequence of mental states. Sequence of mental states is a sequence of mental representations plus semantic. This sequence of mental representations plus semantics, in turn, is a sequence of concepts. Okay, so we have concept 1, concept 2, concept 3, and so on. Okay, so let's do this. Let's work on a simple Python program that basically takes as input a piece of text, and from the text, it extracts the concept with an LLM. Then we link the concepts together, and we see if we can perform some graph algorithms on that network, some clustering, community detection, and so on, and see what we get out of there. Okay. All right. Okay, so I have my VS Code set up. I added some text example here. This is a poem. It has some nice structure that we can use for extracting concepts and topics maybe. This is a good starting point. Later on, we're going to try with a more complex or longer text. The first thing I want to do is to, well, define how to extract concepts with an LLM. And I want to do it in a way that is sentence by sentence. So I'm going to go, that's my window. So I'm going to go over each sentence in this text, and I'm going to extract the concepts for the sentence and then map the concepts to the sentence. Now, before doing that, actually, I want to also chunk the text. And that is because I want to give the LLM some context about the concept in the sentence. So it's going to be something like the following. It's going to be basically a text, and then we're going to take the chunks, okay? And then we're going to get the sentences for each chunk, and then we're going to extract the concepts. All right, so that is the process here. So let's go ahead and start writing our nice little function. So we're going to say def, we're going to say LLM extraction. And this is going to be basically the function that extract the concepts from the piece of text. So let's go ahead. I'm going to call, or I'm going to start here declaring an array, a list called triplets. What is this? This is a list with concept 1, concept 2, and relation, right? This represents basically the unit in the graph. So we're going to say this is basically a triplet of concept 1, concept 2, and relation. The relation between the concept 1 and the concept 2. Now, let's go ahead and we're going to say that we want to chunk the text. So the result here is going to be called res. It's going to be from another function we're going to define now called I don't know, chunk text. Okay, did I spell it correctly? Yep, chunk text. And we don't need to pass a text because we already have the text up there. It's defined. All right, so let's go ahead and define this function here before continuing. So I'm going to go create a new one cell, put it here. I'm going to say def chunk text. The idea here is exactly that we take the input text and then we chunk it. Now, to chunk the text, we have many ways to do it. We can use a rolling window and so on. What I'm going to do here, I'm going to basically use LangChain. It provides already a lot of nice functions for us. And that is going to be the recursive character text splitter. Okay, so I want to chunk the text into chunks based on characters, a number of characters. So we can say that we can add another cell here. We're going to import from LangChain our library. Okay, so we can do from LangChain import from LangChain dot text dot text splitter import recursive text splitter. So now we have our text splitter. We are going to go here in the chunk text and we're going to say that this is, we define this text splitter and this is the recursive text splitter. So we're going to give it some parameters here. So we're going to say that chunk size, this case is very small, 150 characters. That is because our input text is very short. We can change this for longer text. We're going to do a chunk overlap of, I don't know, maybe 20 is fine. Then we're going to say that the length function is equal to len. Then is separator regex false. And finally, we have separators. Okay, and the separators here in this case are going to be, we can use the period. Actually, we can use this. And then maybe something like new line like that. Okay. All right. So now we have our text splitter. We want to create obviously the chunks. And now what we can do is, since we need a document to pass into the text splitter, we're going to create first a document. So we're going to say this is equal to a document, or again from LangChain, where the page content is equal to our input text. And we can also pass some metadata here. We're going to say that this guy has a title of, I don't know, poem, for example. Okay. All right. Now, obviously, we have to import the document. All right. So we have the document. We have a document here. That is good. Now, what we want to do, we want to split this thing. So we're going to say that the pages that we get out of the chunks is our text splitter, and we apply our split documents to our documents. All right. And then what we want to do is to return the single chunk. So we're going to say return a list where we have a page and page content, page metadata for all the pages in our list of pages. All right. So what we can do, we can just try to print this out now and see if everything works as expected. So let's invoke it. And there we have the chunks. Let's add more chunk size here. Otherwise we don't give any context to this poor guy. Yep, There you go. Okay, so now we have the context. Now the next step is we have our chunk text here. We have our chunks. We want to go over each chunk and extract the sentences. So we can say for text, and then we have metadata in res. Okay, and you see that I return exactly a piece of text and metadata, so text and metadata here. Now, for the sentences, I'm going to use Spacey, which is a very good Python library for NLP, super fast. You can select here the operating system, the platform, configuration, the pipeline, and so on, efficiency, accuracy, and this is very, very good library. So I'm going to use this one that gives us already the sentences from the piece of text. Now, I already installed it in my environment, so I just need to import it and use it basically. But how it works is like the following. We're gonna do an import Spacey, like that. Now we are going to create a new cell. We're gonna call NLP is equal to this. This is basically, you create a pipeline. Spacey works as a pipeline that you can throw in text, and it gives you out some information, some data. You do need to download a model with Spacey. I downloaded the medium-sized model. There is also a transformer-based model, by the way. And now, let's load this thing and be sure that everything works as expected. Okay, so it's pretty fast as well. Now, to show what I mean, we can do something like this. We can call our NLP pipeline over the text, okay? And then we can say that, there you go, it already knows. Care about is actually the sentences. And indeed, I'm gonna do a break here and a break here just to see if it prints the first sentence and everything works as expected. Okay, let's see. And it gives us our first sentence from the first chunk. That is very good. All right, what we want to do now is to extract the triplets of concept 1, concept 2, and relationship for each sentence. Okay, so we have the sentences, we extract the concepts, and we extract the triplets actually for each sentence. So what we're gonna do is to say something like this. Triplet is gonna be equal to extract triplet from the sentence text. We're gonna define this function in a second, and then we're gonna say that we can append. Actually, I want to just extend this vector with the triplets. So I'm gonna have a big long list of triplets that we can use, for example, to create a pandas data frame or something like that. Now we do need to define this, and this is actually the fun part. This is where we use the LLM. We give a text here, okay, like that, and the context, and we are good with that. So we're gonna say that this is the chat. It's gonna be equal to chat OpenAI. We're gonna use that, define the callback here. So we're gonna have an API key. And this is gonna be my key. So it's gonna be open API. Actually, I call it OpenAI API key. There you go. And the model name is gonna be Turbo. I think there is another one that is a little bit better, 0125. I'm gonna say temperature is equal to 0, because we want to be consistent here, deterministic as much as we can. And then this really doesn't matter, let's say 1000 tokens already. So now we have our chat. What we're gonna do now is to do the system message. So I'm gonna say system message prompt. I'm gonna call it like that, and I'm gonna say this is going to be our system message. Now we need to pass something here, and what we can do. So it's going to be something like this, right? We provide the content of the system message. Now, I want to do something else. I'm going to create a new file and call it prompts.py. I'm going to add all my messages in here. So I'm going to say system message. This is going to be something like, you are a helpful assistant, okay? And this is just for testing. So we're gonna go inside here and say from this, in this cell here, we're gonna say from prompts, import everything you have. Let's run this. And now we are going to say that our system message is our system prompt. System message is going to be our system message prompt, which is an object of type system message, okay? Now we are going to do the same for the human message prompt, and we need to do a from template here, actually. And then in the from template, we are gonna pass our task. Okay, so we're gonna say that this is what we want the LLM to do. So we can go here and say, look, this is a task message, and you can say, tell me a joke, for example. Ready? So we're gonna use it here. So, okay, that is good. And since we want to pass some variables, we can also go back here and say, tell me a joke like this about topic. All right. So we're gonna get here. We're gonna get the task message. Now we need to create the actual prompt here. It's gonna be chat prompt, and this is gonna simply be a chat prompt template. And we are going to give here basically the list of messages, prompts that we want. So this guy, and then it's gonna be this guy as well. Oh yeah, from messages, right? Yeah, because we have our, wait a second, chat prompt template from messages. From messages, yes, okay. So the chat prompt template, you can create one from the messages that you give it in input, and these are the messages that I want to use. So now we are gonna say, okay, give me the actual messages that I need to give to the model. And this is gonna be chat prompt. And we need to format it. Format messages. And what do we need here? Actually, format prompt. What does this say? Well, this is used to actually pass our variables into the prompt, and our only variable that we have here is the topic. So we're going to say chat prompt, format the prompt using the topic variable. I call it, I don't know, tell me a joke about, programmers. There you go. Now we have the message. You can say that you format the prompt and you convert it to messages. All right. And now we can actually finally invoke our LLM. So we're going to say response, let's call it res is equal to chat.invoke messages. And then what we want to do is to just simply print this. Okay. And then since we have to return a list, we're going to just return this guy, an empty list for now. So we have this, extract cliplets, we return this, we extend with nothing, we break, and we break down here. Right here. So we run only once, and then we can simply run this. Let's see if it works like this. Okay. All right, so the pipeline works. The next step is to actually create the system prompt and the task prompt. And to do that, I'm going to use directly the playground. It's a little bit faster here to iterate. And I can start doing this offline and then come back with the actual prompt and some examples here after I did that. Okay, here we have our system prompt and the user message. So what I do here is the following. I'm gonna tell the LLM that is a graph maker that extracts concepts and relations from a given text. It is given an excerpt of text and a target sentence from the excerpt, and the excerpt of text serves as a contextual information for extracting concepts and relations. Okay, then I'm going to specify the task. I'm going to say that the task is to extract an ontology of terms and relations between these terms from the given sentence. The terms represent the key concepts in the sentence that have meaning with respect to the context. Okay, so we extract the concepts from here that make sense in relation to the context. Now, the framework is going to be the following. I'm going to prime the LLM saying that we are referencing the RTM, and then I'm going to specify what concepts are. This is the part that we didn't touch in the intro, which was to define the meaning of concept. Concepts are defined as entities, and these are things that have a distinct and individual existence, or concepts are events, or they are abstract concepts. Then we have the procedure, and then I provide an example from this excerpt here, where for the first sentence, actually, to my Chris, I've been thinking about how I could possibly tell you how much you mean to me, where the source is I, the target is Chris, and the relation is express feeling towards. Okay, and then I go ahead with the other concepts here. All right, so now we have that prompts here. Now the next step is to actually run this thing. And what I did offline was to, was to clean, actually, I was about to say, was to clean the output a little bit, but now that I see here, we also need to change this to the proper variable. So we have context. This is going to be context, and then we're going to have the target, and it's going to be the text, because we have text and context, and here we have context and target. Okay, context and target. So this is all set. Now we are going to rerun everything, and I'm going to explain what I do for cleaning this thing. Okay, so now I show you what I do here. I first strip the result and then add missing commas. This is a utility function I created, and it's basically a simple function using regex that adds some commas where, well, it adds some commas here because sometimes the LLM produces these results without adding a proper comma, and it gets tricky for the JSON to actually transform this string into a JSON object. And then I remove some double commas like this. Okay, so we have the result. So what we want to do next is to, well, print this thing. So we're going to say try, and we're going to say that our JSON result is JSON loads. You load the result here. We're going to import the JSON. So I'm going to say import JSON. All right. And then we are going to say, okay, if it is not working fine, what we want to do is to, well, let's do a print debugging here and just put some stuff like this so I can clearly see the output. Then I'm going to say print res, and then we return this empty list here, right? We don't want to break everything, so we just want to return the empty list. Now, what I want to do as well is for the result in JSON result, I want to say that R, I want to call this an edge. This is going to be R, and explain now what I mean here, relation. And then I'm going to say that R dot ID is going to be is equal to, we can say something along the lines of uid.uid4, something like that. And now explaining to you what I mean with this. So we're going to import UUID here. And then we're going to convert it to a string when we go here. So we're going to say this, and we are going to say like this. Okay. Now I do this because then I'm going to work with network X, and I want to have a source, a target, and an edge in the list of attributes. So network X can create a graph out of those 3 attributes. All right, so, and then obviously we want to return not an empty list here, but we want to return the JSON result here. Ready? Okay. So let's go ahead and try this now. Okay, let's print triplet and see what we get as a result. Now we can run this guy. We should run the pipeline, chunk, sentence, and triplet. So we have source, target, semantics. Okay, this seems good. The edge, the ID. Perfect. I think this is what we want now. I'm going to instead create a pandas data frame and then save it as a CSV file so we can load it later on and reuse it without actually running the LLM. So here I'm gonna say that I want my pandas df. Actually, let's just call it df, and then we have g, and I'm gonna say get data frame graph, and I pass a triplet. The data frame graph function is a utility function I wrote here. Doesn't do much. It creates a pandas data frame from the triplets from the list, and then I use the data frame to create a network X graph. It's network X. So now if I go ahead and say something like print df, we should see data frame, and also I would go ahead and also store it like this. So I'm going to say the data frame to CSV, and I'm going to say maybe poem CSV. Okay, let's go ahead and run this now and rerun the program. Okay, seems reasonable enough, and here we have our CSV file with everything we need. So we have the semantics, the edge, which is the relation. Okay, this is not too bad. So the next step is actually to go ahead and read the poem from here. So we have the extraction. Okay, now we want to add another cell. We're gonna load the data frame. So I'm gonna say df is gonna be equal to pandas read CVS from the file, and then we are going to filter this thing, the data frame, by age, by certain columns. Those are the columns that we need to use in our network. So we're gonna say that df is gonna be df of my columns, and I'm gonna say we want the source, then we want the target, and then we want the edge. It's gonna be a relation between the source and the target. So this is my new data frame now. From by this network import network, that is okay. I'm gonna say that my network is equal to a new network, and I need to pass the dimensions here. So height 750, width 100%. Yeah, that seems okay. Now we need to pass in it. We can definitely load it like this from the graph. You can also customize this thing. So you're gonna say for the rows in the data frame, you can add the add node, so the source with the label, and then we have the other node, the target with the label, and then we can add an edge, and you can pass the label for the edge. Okay, so now it created a HTML. Okay. All right, perfect. So this is already cool, in my opinion. There you go. We don't have the name, the labels on the edges, but it doesn't really matter. I mean, we can add it in a second. We can do that. What you see here is the actual concept graph. So we have I, which is a central hub here. And that makes sense, right? The author is actually writing first person, so I and everything else around it. And then you, which is the other hub here, that makes sense because the author is referring to you, to Chris here, you see. Let's try to modify this and add actually the labels, okay? And then once we have the graph, we can do a lot of fancy stuff on it. Okay, created this. We refresh. Boom. Nice. Okay. Well, it's a little bit hard to read, but I think this makes a little bit more sense when we zoom in. I probably need to change the forces here, pulling the nodes together. But basically, if you see this thing, we have I directly addresses you, so I talk to you, okay, and you share location with describes size of tiny, so share location with apartment, and the size of the apartment is tiny. So we have some kind of information here. Now, how do we use this? That's the real question, and we can again apply some graph algorithms. I want to see if there is a way for us to actually follow a thinking process between concepts. All right, so that's about it for this video. I hope you enjoyed the video. To recap, we started from a piece of text. We wanted to create this social network of ideas. We got to build with an LLM a graph that represents a concept graph, where the nodes are the concepts, and then the edges are the relationship between these concepts. Following a path in this graph is basically following a thinking process, and that gets translated in some way to the text that we use to extract the concepts from. Now, we have a concept graph. In the next episodes, what I want to try to do is to, first of all, improve this graph, try it out on a longer piece of text, but also try to merge a concept graph with a knowledge graph, plug in some entities, for example, or relationships and so on, and see if we can make this graph a little bit more meaningful. So I want to pair ideas with actual knowledge of the world, combine them together, and then run some algorithms, graph algorithms on it. We can run some, for example, community detection, topical clustering, and so on. So we can identify more or less what's going on in the text, what are the main topics, if there are gaps, if we are able to connect ideas, if the LLM can help us connect ideas. So there are a lot of fancy things that we can do on graphs, but this is just the beginning. I hope you enjoyed. If so, well, I'm glad, and I hope to see you in the next video. Thank you.